Welcome back. This is 7.2 permutations. So our objectives for today are using the fundamental accounting principle to count permutations, evaluate factorial expressions, and use the permutations formula, and then find the number of permutations of duplicate items. So permutations is an ordered arrangement of items that occur when no item is used more than once. The order of arrangement makes a difference. So let's look at an example. So it says you need to arrange 7 of your favorite books along a small shelf. How many different ways can you arrange the books, assuming that the order of the books makes a difference to you? So you can choose any one of the 7 books for the first position on the shelf. This leaves 6 choices for the second position. After the first 2 positions are filled, there are 5 books to choose, and so on. So how we write that is we have 7 choices times the 6 choices times 5 times 4 times 3 times 2 times 1. And then we multiply that all in our calculator, and we get 5,040. Okay, so each time you're taking away one of the numbers because you used that already. Like a book, you don't have like multiple books of that same book. You only have the one, so you can't reuse it in another spot. All right, factorial notation. So the product 7, 6, 5, 4, 3, 2, 1 is called 7 factorial and is written as 7 exclamation point. So factorial notation, if n is a positive integer, the notation n factorial is the product of all positive integers from n down through 1. Oh, there needs to be an h there. And then it's written as n exclamation point equals n times n minus 1, n minus 2, n minus 3, all the way leading down to where it's just 1. 0 factorial, by definition, is 1. So if ever you see 0 factorial, it's always a 1. All right, so using factorial notation, evaluate without using your calculator. So how we do this is we're going to write out all of our multiplication. But notice we have a 5 factorial on the bottom. So if we write 8 times 7 times 6 times 5 factorial, because that's going to include everything below, and then it's still over 5 factorial, we can cancel that 5 factorial out. So all we have left is 8 times 7 times 6, which if you put it in your calculator, you have 336. So that goes with any number. You can break it down until you get to the one that's in the bottom. So let's do the next one. So 26 times 25 times 24 times 23 times 22 times 21 factorial, because that's what the bottom is, all over 21 factorial. So we're going to cancel it out, and we have what's left, 26 times 25 times 24 times 23 times 22 equals, and then you put that in your calculator, you multiply all those numbers together, and you get 7,893,600. All right, so next we have 499. So to get to 499, it's just one number away. So 500 times 499 factorial over 499 factorial. Okay, we cross those off, and it just equals 500 because that's all we have left over. All right, the formula for permutations, it says permutation of n things taken r at time. So the number of possible permutations if r items are being taken from n items. So we call that NPR, which is your n factorial over your n minus r factorial. So it says you and 19 of your friends have decided to form a business. The group needs to choose 3 officers, a CEO, an operating manager, and a treasurer. In how many ways can those offices be filled? So your group is choosing 3 officers from 20 people. And the order matters because each officer has different responsibilities. So that's going to be your NPR, so 20 permutations of 3. So we write it as 20 factorial over 20 minus 3 factorial. So you do that inside parentheses first. So 20 minus 3, we get 17 factorial. And then remember, you break up the top. So 20 times 19 times 18 times 17 factorial. So once you get to that number on the bottom, you stop. And then we can cancel them out. So you have 20 times 19 times 18, which if you put it in your calculator, you get 6,840. So that's how many different ways you can choose the offices. So that's a lot. A lot of different options there. All right. So a formula for permutations of duplicate items. So in how many, reading ahead here, sorry. So it says the number of permutations of n items where p items are identical, q items are identical, r items are identical, and so on is given by n factorial, p factorial, q factorial, and r factorial. And so on, if you have different things you're choosing from. So it says, how many distinct ways can the letters of the word Mississippi be arranged? So the word contains 11 letters. So that's your n, that's your parameters. So where there are 4, because you can't add more to Mississippi. There's nothing to add to it to make the word Mississippi. It's stuck with those 11 letters. So where there are 4 identical I's, so P equals 4, 4 S's are identical, and that's Q equals 4, and 2 P's are identical, so R equals 2. So the number of distinct permutations are n factorial, so 11 factorial, over P factorial, which is 4 factorial, then 4 factorial for Q, and then 2 factorial for your R. So we want to get rid of one of our factorials in the bottom. So we would have 11, 10, 9, 8, 7, 6, 5, 4. So that's where we stop because we have a 4 factorial in the bottom. So cancel those out. So you have 11 times 10 times 9 times 8 times 7 times 6 times 4. Oh, no, not 4. We got rid of the 4. And then divided by 4 times 3 times 2 times 1. So that's that 4 factorial is those numbers. And then 2 times 1 is that 2 factorial. So if you put that in your calculator, make sure you do parentheses around the top and the bottom. When you do that division, you end up with 34,650. And that's it. All right, we are done with the notes for 7.2. If you have any questions, please let me know. Otherwise, go ahead and work on your assignment.